This lecture discusses food packaging materials and impacts. So let me begin by mentioning the roles of food packaging, which are to protect food products from outside influences and damage, to contain the food, and to provide consumers with ingredient and nutritional information. Traceability, convenience, and tamper indication are secondary functions of increasing importance. So one could say that the goal of food packaging is to contain food in a cost-effective way that satisfies industry requirements and consumer desires, maintains food safety, and minimizes environmental impact. The types of packaging material include paper and paperboard, glass, metals, which include steel and aluminum, and polymer packaging or plastics, which include single materials, flexible packaging, and multi-material packaging. To give you an idea of multi-material packaging, here's a graphic that shows your standard potato chip bag, which is comprised of 4 different layers. The first layer is polypropylene, which is in physical contact with the food. Then there's nylon, which serves as an abrasion resistant. And then there's aluminum foil, which is really important for keeping out gases and odors and extending the shelf life. And finally, there's a layer of polyester, which is good for printing. The hybrid nature of this packaging makes it almost virtually impossible to recycle. Although I've seen some great handbags and textiles woven with this material. Here's a table that lists the recycling codes for a lot of packaging. I would say that number 1, PET, polyethylene terephthalate, is very popular. Same with number 2, which is a high-density polyethylene. Skipping over to number 4, which is a low-density polyethylene, is a popular recycling symbol, as well as number 5, the polypropylene. Moving over to the chemical formula, I want to point out that polyvinyl chloride has chlorine in it, and this is of concern when this material gets incinerated or when it's sent to a waste-to-energy plant. Also, it's interesting to note that number 2 and number 4 are actually the same chemical formula, just that the way they get treated, one is of a linear and one is of a long-branched polymer. So packaging from number 2 and number 4 can actually be commingled into the same resource stream. Here's a chart that shows the top 10 plastic containers by volume 2014 and projecting out to 2019. Almost all these categories are growing. There's also a lot of plastic in here, HDPE bottles, there's thin wall plastic containers, there's PET bottles, and flexible plastic is by far the most dominant of the categories. Every 5 years, the Environmental Protection Agency conducts a study of municipal solid waste trends, including the generation of materials as well as the recycling of those materials. This chart, which ranges from 1960 to 2014, shows us a few different things. First, we can see that the generation of paper is going down, that glass and metals is staying about the same, and that both food and plastics are definitely on the increase. When we break down the information to show containers and packaging, it turns out that there's about 75 million tons of container and packaging in municipal solid waste, which is about 29% of the overall waste stream. By grouping together yard waste and food waste, we can also see that about 28% of this material is potentially compostable. And likewise, by grouping together plastics, metal, glass, and paper, we can see that 59% of this material is potentially recyclable. However, when we look at the actual recycling, composting, and energy recovery data, we can see that compost is actually around 8%, recyclables are at 24%, and 13% of trash goes to waste-to-energy facilities, and just over half, 55%, of discarded materials goes to landfill. The takeaway here is that landfill material is holding about steady, and that it would actually be growing if it wasn't for the fact that composting and recycling has been increasing. Meanwhile, combustion with energy recovery has been remaining somewhat flat. And when we look into the landfill to find out what is in there, we can see that the number one item is food waste at 35%, paper comes in at around 25%, plastics is 16%, 9% of metals, 4% for glass, and 11% of other, which includes textiles and rubber. So while recycling has been increasing, we can see that from the 1980s, 1985, the rate was about 10%. It's moved up to the mid-30s. We also can see that the rate has been flattening out in recent years. Of course, the macro trends can obscure some of the micro trends, and here's one positive one for aluminum can weight. We can see here that in 1972, aluminum cans were about 20 grams apiece, and around in 2014, they've dropped down to 12.99 grams each. Another specific and daunting trend has to do with plastic generation. This chart shows that plastic generation has skyrocketed from 1960 to 2014. Meanwhile, recycling rates for plastics have reached somewhere between 3 and 4%. So when policymakers consider food packaging, plastics is a major concern. Here are 3 items that have come from a recent study by the Ellen MacArthur Foundation that was just published. The first is that most plastic packaging created is wasted. Secondly, nearly a third of plastic packaging winds up in the environment. And third, the hidden costs of the negative environmental impacts exceed the plastic packaging industry's profits. To read this full report, you can Google "The New Plastics Economy: Rethinking the Future of Plastics." The next lecture will look at how municipalities and businesses are trying to tackle this issue.